Good news, this is the last chapter of trig. The bad news is, it's still trig. This is precalculus 5.1, using fundamental identities. So get out your formula sheet. It's on the unit circle. We'll be using those trig identities. The first problem we're going to do is example 2, page 355. If you want to look from the book, we're going to simplify sine x cosine squared x minus sine x. Now, if you'll see, there's something common that they have. Let me check, and let's see, I'll use, this looks like a nice color. Alright, there is a sine x that's common in both of these. So what we're going to do is we're going to divide it out. We're going to simplify it out or undistribute. So I'm going to take the sine x out, which means if I take the sine x out of the first term, that crosses off, and that leaves us cosine squared x minus, and then if I take the sine x out of the second term, I get minus 1. So now I have sine x times cosine squared x minus 1. And if you look on your identity sheet, there is an identity that has 1 and sine or cosine squared in it. It's sine squared x plus cosine squared x equals 1. Now this is close. If I subtract cosine squared from both sides, I get sine squared x equals 1 minus cosine squared x. But since we have cosine squared x minus 1 instead of 1 minus cosine squared, this is equivalent to negative sine squared. If we just change the signs, now we have it in the right order. So this right here can be replaced with negative sine squared x. So I have the original sine x out here times negative sine squared x, and our answer then is negative sine to the third x. Okay, now that is how we simplify something like that. Now we're going to go to example 3, and we're going to factor. We have secant squared theta minus 1. We're going to factor that expression. It's not an equation, just an expression. We're going to factor that. Now I want you to think of this as though it were x squared minus 1. How would you factor that? It would be x plus 1, x minus 1. It's a difference of squares. This is also a difference of squares, so you take the square root of secant squared theta, and that'll be the first term, which is secant theta. That's going to be the first term in both binomials. And then take the square root of 1, and that's 1. And then we have our plus and minus. And there is that one factor. This is on page 356, by the way. Letter B is a little trickier. It's 4 tangent squared theta plus tangent theta minus 3. Now, the tangents are probably what's looks a little intimidating. So if I pretend this is 4x squared plus x minus 3, and then we were to factor it from here, let's see, if I try 4x and 1x, can I get, let's try this out, that's minus 3, that's plus 4, I didn't really think I'd get it the first time, but I did. This gives us 4x, this gives us negative 3x. When we add them together, we get x, which is our middle term. So this is the right factorization. However, x replaced the tangent. So what I had done is actually taken tangent theta and I put in an x for it. So now what I need to do is I need to turn that x back into a tangent theta. So I have 4 tangent theta minus 3 tangent theta plus 1. That's my factorization. And that's as far as I can go. Alright, now we have another factoring problem. The only difference between this and this is that we have two different trig functions. So in order to be able to factor this, it has to be in the same function. So I have to go back to my list of identities. And if you will look at your identities, a lot of them have to do with the Pythagorean identities. Those are the ones where you can actually go from one unit or one trig function to another. So I'm going to focus on my cosecant squared x, because this is a squared and that goes along with the Pythagorean. So I'm going to look up the Pythagorean identity that has a cosecant squared in it. And here I have 1 plus cotangent squared u equals cosecant squared u, or x. What that means is I can take this and I can replace it with this, and that would be a good thing since it's a cotangent and this is a cotangent. Then I would have the same trig values. So I'm going to go ahead and change colors here. So many to choose from. Let's do yellow. Alright, so I'm going to replace that right there. I'm going to put 1 plus cotangent squared x. That goes for this, that's that one. Minus cotangent x minus 3. And if we simplify this out, we'll have cotangent squared x minus cotangent x, and 1 minus 3 gives us a total of minus 2. Now if I pretend that this is x squared and this is x, so cotangent x is equal to x. We're just replacing it. So now I have this. When I factor it out, here let's do this, x and 2 and 1, and it's got to be a negative right here, so that's the negative and that's the positive. So I'm going to go back to my yellow. And I'm going to replace the x with cotangent minus 2 and cotangent x plus 1. And there is that, as far as I can go with that factoring. Okay, so we are on to example 5 now, and we get another simplify. Love simplifies. Now what I can do is, what I'd love to do on these is change all trig notation into sines and cosines. So if I look on my trig identity, I'll take this cotangent x there, and the cotangent is actually equal to cosine over sine. So I'm going to go ahead and change this. So I have sine x plus, I'm changing this to cosine x over sine x times the cosine x that's already there, which is over 1. So really I have sine x plus cosine squared x over sine x, but this is over 1 and this is over sine x, so I'm going to get common denominators. Okay, which is sine x. So I'm going to take this by sine x and this by sine x, and that will give me a common denominator. I'll change color again, and I get sine squared x over sine x plus cosine squared x over sine x. And when you put them all over the same, since they have a common denominator, we can do this. Sine squared x plus cosine squared x. And that actually gives me, I can cross that off because that's a Pythagorean identity, and that's 1. So I really have 1 over sine x, but if I don't want it in fraction form, I can change that into its cousin, which is cosecant x. So that would be my answer right there. Alright, we're almost done. We have example 6 here, and we have to perform the addition and simplify. Now, whenever you're adding something with fractions, you have to get a common denominator. So, I have 1 plus cosine theta on this side, and I have sine theta on this side. Nothing in common between them, so I'm going to go ahead and just multiply by the other term. So over here, I'm going to multiply by sine theta over sine theta. And on this side, I'm going to multiply by 1 plus cosine theta, 1 plus cosine theta. And let's just see what happens. Over here, let's do this. I'm going to use this. I've got sine squared theta over, ooh, a bunch of yucky stuff. Let's just leave it separate right now instead of distributing it through. Let's see if that'll work for us. We may have to distribute it later. Okay, up here though I am going to distribute because they're cosines, so they're going to have some commonalities. So I'm going to take cosine x plus cosine squared, theta, over sine theta, 1 plus cosine theta. Now because they're the same denominator, I can go ahead and put all of my numerator stuff all together. So on top I have sine squared theta plus cosine theta plus cosine squared theta. Now if you'll know, this and this, when you put those two together side by side, you get 1 from the Pythagorean identity. So this actually turns into 1 plus cosine theta over sine theta, 1 plus cosine theta. And look, 1 plus cosine theta cancels out with 1 plus cosine theta, giving me 1 over sine theta, and we'll turn it into its cousin again and call that cosecant theta. And that's my answer. Alright, we have one more problem, so let's take a look at it. It's example 7. We have to rewrite 1 over 1 plus sine x so that it is not in fractional form. So somehow we're going to have to change this so that it turns into something that can be written all on one line. So 1 plus sine x is a 2-term, it's a binomial, and it's kind of ugly. So what I need to do is I need to be able to get it down to 1 term. Well, I know that I can use my Pythagorean identity sometimes to get the fraction form out. Now, let's take a look first of all. If I had, remember these ugly decimals that we used to have to get out. Let's go with when you couldn't have a square root in the bottom. So we have square root of 2 plus 1. How would I get that square root out? We would use what's called the conjugate. So I'm going to take this by its conjugate, which is the exact same two values but with a different sign in the middle, and then I would do that. Okay, now knowing that, let's go ahead and use that conjugate in this problem. So I have 1 over 1 plus sine x. what I want to do is I want to use the conjugate of the denominator. So I'm going to multiply by 1 minus sine x. There is a purpose. You will see what that is. Alright, now 1 times anything is still the same thing. So I have 1 minus sine x on the top. And on the bottom, when I FOIL it out, or just double distribute, I get 1 minus sine x plus sine x minus sine squared x. Okay, now these two cancel out, so I have 1 minus sine x over 1 minus sine squared x. This should ring some bell. It's a Pythagorean identity. It actually can be replaced with cosine squared. So now we have 1 minus sine x over cosine squared x. Now nothing cancels out here. This is just a sine right here. It's not a sine squared, so it's not going to turn into anything using the Pythagorean identity. But we do know that our goal was to get it so it's not in fraction form. Since this is one term and I have a cousin of this term, I can call this, it's really like saying 1 minus sine x times 1 over cosine squared x. So what I can do is I can write this as 1 minus sine x times, and you remember using that other trig identity, that the cousin of cosine squared is secant squared, so that would be on the top. So this right here is this problem, this problem written all in one line and not in fraction form. Alright, that's all I have for you. Good luck.